In this lesson, we're going to do a review of some geometry, and we're going to work with right triangle trigonometry. There are 6 functions that we'll be using: sine, cosine, tangent, cosecant, secant, and cotangent. Please remember that cosecant is simply the reciprocal of sine. So cosecant is 1 over the sine. Secant is 1 over the cosine, and cotangent is 1 over the tangent. So let's do some review. Theta is the Greek letter that represents the angle that we're talking about. So when we are talking about the parts of our right triangle, the side that is across from the 90-degree angle is always the hypotenuse, and it's the longest side. Directly opposite or across from the 90-degree angle. Adjacent means that this side is right next to our theta, our angle that we're talking about. It's also called one of the legs of the right triangle. And then our opposite side is directly across from our theta. It's also a leg of our right triangle. And remember that this is our 90-degree angle. So when we are working with our trigonometry, there's a little word that helps us remember what relationships we have for our trig angles, and it is SOHCAHTOA. So SOH means that sine is opposite over hypotenuse. And from the previous slide, we know that cosecant is the inverse or reciprocal of the sine. Cosine, CAH, is the adjacent side over the hypotenuse. And the secant is simply the reciprocal. And then tangent, TOA, is opposite over adjacent. And cotangent is going to be the reciprocal, adjacent over opposite. Okay, so we need to figure out some of these relationships. So the first thing we do when we have a right triangle is we're going to circle the theta. And then we want to label each of the sides. This is the hypotenuse. The 5 is the adjacent because it's right next to the theta attached to it. And the 12 is the opposite because it's directly across from our theta. Let's write our SOHCAHTOA in. Okay. So sine is opposite over hypotenuse. And cosecant is simply the reciprocal. Cosine, adjacent over hypotenuse. Secant is the reciprocal. Tangent is opposite over adjacent. Cotangent is the reciprocal. Now what happens if we are given 2 of the sides and we're missing the third? Well, first of all, here's our theta. We know that the side directly across is our opposite. We know that the side attached to our theta is the adjacent, and we know that the longest side across from the 90-degree angle is our hypotenuse. So now we have to go back to our geometry, and we are going to do the Pythagorean theorem. A squared plus b squared equals c squared. Please remember that our a and our b are the legs of our right triangle, and the hypotenuse is always the c value. So it doesn't matter which adjacent or opposite that you put in, but we have 10 squared plus 5 squared equals c squared. So 100 plus 25 equals c squared. So we have 125 equals c squared, and we take the square root of both sides. And if we make a factor tree for 125, there would be 25 times 5 and 5 times 5. So we could bring a 5 outside, and then we would have a 5 inside. So our c value, which is our hypotenuse, is 5 square root of 5. So remember, we have our SOHCAHTOA. So sine is opposite over hypotenuse, which is going to be 10 over 5 square root of 5. And our cosecant will be the reciprocal. Cosine is adjacent over hypotenuse, so it's going to be 5 over 5 square root of 5. And secant is going to be 5 square root of 5 over 5. Tangent is going to be opposite over adjacent, so 10 over 5. And the reciprocal is 5 over 10. Now we should go back and we should reduce. So 10 over 5 simplifies to be 2, and 5 over 10 simplifies to be 1/2. On the secant, the 5's will simplify, so you simply have the square root of 5. And on the cosecant, we can divide both of these by 5, so it's going to be the square root of 5 over 2. Now, the problem with the next one, when we do our sine, is that this will simplify. We can divide both by 5, so we get 2 over the square root of 5. And this one simplifies, so we have 1 over the square root of 5. But remember, we don't want to leave the square root of 5 in the denominator. We need to rationalize it, so we're going to multiply both the top and the bottom by the square root of 5. So we have 2 square roots of 5 over 5, and that's going to be our answer for our sine. For cosine, we're going to multiply the top and the bottom by the square root of 5. And so we have the square root of 5 over 5, and that's going to be our cosine. Okay, now we want to take a look at solving and finding missing measurements. So if you recall, when we are doing angles of a triangle, this is our 90-degree angle. And the sum of the angles of a triangle is 180 degrees. So far we know that the right angle is 90 degrees. And we know that the angle given to us is 62, so that's 152. And if we take 180 minus 152, that's going to give us the angle that's missing, which is 28 degrees. So now we know all three measurements. Now, we are going to circle the 62 since it was given to us, and that's going to be our theta. So that means that the 6 is our adjacent side. Our other side, B, is going to be our opposite side, and our hypotenuse is going to be C. So remembering our SOHCAHTOA, we want to use our 62 degrees and our 6 degrees to find the missing sides. Since we know the adjacent side is 6, we could use cosine because we want to use one of our measurements that has an A in it. So the cosine of 62 degrees equals, and remember cosine is adjacent over the hypotenuse, which we don't know what it is, so we're going to call it letter C. So we're going to have to solve to find our answer. To do that, we're going to multiply both sides by C. So we have C cosine of 62 degrees equals 6. And then we're going to divide both sides by cosine of 62 degrees. So what we will do is we will use our calculator. And so if you take 6 divided by the cosine of 62 degrees, and you can use your phone, it has cosine on it, you just have to turn it sideways. And you should get approximately, and we'll have to round, be 12.8. You should practice trying this on your calculator. Okay, now I'm missing B, which is the opposite side. So since I'm missing opposite and I have adjacent, I'm going to do tangent. So tangent of 62 degrees equals opposite, which is side B, over adjacent, which is 6. So I'm going to multiply both sides by 6. So on my calculator, I'm going to take 6 times the tangent of 62, and that should equal B. So when I plug that in my calculator, I get 11.3 after I've rounded, and that would be the measurement of the B side. Okay, we have some more practice using our calculator, and make sure that your calculator is in degrees. If you are using a calculator, if you're using your phone, it should be in degrees. So cosine, and it says to round to 4 places, is 0.7986. Make sure you're practicing this as we're taking our notes so that I know you can operate your calculator. Tangent of 12 degrees is 0.2126. When we're doing the secant, remember that's 1 divided by the cosine of 54 degrees. So you'll take 1 divided by cosine of 54, and that is 1.7013. And cotangent is 1 divided by the tangent of 72 degrees, because you notice on your calculator that you only have sine, cosine, and tangent, and that's 0.3249.